Welcome to a webcast made by the Learning Enhancement team based in the Dean of Students office at the University of East Anglia. This webcast is part of the Bridging Between Algebra and Calculus series and concerns sketching a graph. This guide discusses the skill of sketching a graph. It gives methods to help you understand how to sketch a graph from given function. Introduction. It is not unusual in mathematics to be asked to sketch a graph of a given function or functions. This often happens when a quick impression of the shape of the function is required, rather than an accurate plot or computer representation. This regularly plays a part in calculus, for example, sketching a curve with stationary points, or finding a region of integration. See study guides, Finding Stationary Points, and Definite Integrals. It is important for you to know the difference between sketching and plotting graphs. A sketch depicts the most important parts of a graph. It does not have to be to scale, although it still has to be labelled correctly, and any lines or points need to be correctly positioned in relation to each other and the axes. In a plot, on the other hand, you work out precise positions of the coordinates of the graph and plot them either using a computer or on graph paper. See study guide, Plotting a Graph by Hand. There is no formalised way to sketch a graph, but this guide offers some ideas and methods which you may want to follow. However, you should always start your sketch by drawing axes on a piece of paper. You should use a pencil and ruler and have an eraser to hand, as sketches often need to be adjusted as they take shape. When you find out some information about your function, you should mark it in roughly the right place on the paper and label it. Eventually your sketch will form and, when you are happy you have all the relevant information, you should draw the function. It is also extremely useful to learn the shapes of basic functions, such as linear, quadratic, cubic, exponential, logarithmic and trigonometric, sine, cosine and tangent. You can also calculate a few points on the graph to help you. The best way to improve your graph sketching is to look at functions, attempt to sketch them, and then use a computer or a plot to see what the function actually looks like. For more details about sketching straight lines, you can read the study guide, Sketching Straight Lines. Important parts of graphs and how to find them. There is a list of questions which you can ask yourself which help you to sketch the graph of a function. Each question is not always relevant to every function, but they form a good starting point. Question 1. Does the function cross the axes? If so, where? To find where a function crosses the y-axis, the so-called y-intercept, you should set x equal to 0 in the function and calculate the corresponding value of y. This value is the y-intercept and you can mark it on your sketch. Most functions have a y-intercept, and it is a good idea to find it first. To find where a function crosses the x-axis, the so-called roots of the function, you should set y equal to 0 in the function and calculate the value or values of x which make this true by solving the resulting equation. For simple functions such as straight lines and quadratic functions, solving the equation is relatively straightforward. See study guides, What is a straight line, Finding equations of straight lines, Solving quadratic equations by factorisation, and Solving quadratic equations using the quadratic formula. Finding the roots of more complicated functions is not as straightforward. There are many mathematical methods dedicated to finding roots, but they are beyond the remit of this guide. You can talk to a learning enhancement tutor for more guidance. Example. Sketch the function y equals x squared minus 4x minus 5. First, sketch your axes. Set x equals 0 in y equals x squared minus 4x minus 5 to find the y-intercept. So, as y equals 0 squared minus 4 times 0 minus 5, which equals minus 5, the y-intercept is minus 5. Mark this on the y-axis. Set y equals 0 in y equals x squared minus 4x minus 5 and solve the resulting equation to find the roots. Factorising 0 equals x squared minus 4x minus 5 gives 0 equals x minus 5 multiplied by x plus 1, and so x equals minus 1 and x equals 5, which means that the function crosses the x-axis at x equals 1 and x equals 5. Mark these on your graph. You can use these 3 points along with the general shape of a quadratic function to produce the sketch on the right, like this. This is a sketch of the function y equals x squared minus 4x minus 5. 2. Are there any asymptotes? If so, where are they? Although there are 4 types of asymptotes, horizontal, vertical, oblique and curved, this guide is only concerned with the first 2 types as they are the most common. If you need advice about the other types of asymptotes, talk to a learning enhancement tutor. 1. A horizontal asymptote is a line parallel to the x-axis of the form y equals k, which a function approaches but never crosses, as x approaches plus or minus infinity. Here, k is a constant. Horizontal asymptotes occur at values of y which cannot be produced by the function, regardless of the value of x. You should find out whether your function approaches the horizontal asymptote from above or below, as x approaches plus infinity and x approaches minus infinity, and use this information in your sketch. You can use a brief table to help you. 2. A vertical asymptote is a line parallel to the y-axis of the form x equals k, where the function approaches either plus infinity or minus infinity as x approaches k. Here, k is a constant. Vertical asymptotes occur when a value of x results in dividing by 0. If you have vertical asymptotes, you should consider what happens as you approach the value k from the left and from the right. Again, you can use a table to find whether the function approaches either plus infinity or minus infinity. Use this information in your sketch. Reciprocal functions, functions where x appears below a dividing line, invariably contain asymptotes. If you are asked to sketch a reciprocal function, then you should begin by finding its asymptotes and what happens as you approach them. Other functions which contain asymptotes are the tangent and exponential functions. See study guide Exponential Functions. Example. Sketch the function y equals 3 divided by x plus 3 plus 2. First start by sketching your axes. If x equals minus 3, then you are dividing by 0, and so the line x equals minus 3 is a vertical asymptote. You can show asymptotes on a sketch with a dotted line, like this. You should find out what happens as you approach the asymptote from the left and the right. As you approach x equals minus 3 from the left, the value of y gets large and negative, as seen from the table below. When x is minus 4, y is minus 1. When x is minus 3.5, y is minus 4. When x is minus 3.1, y is minus 28. When x is minus 3.0001, y is minus 29,998. As you approach x equals minus 3 from the right, the value of y gets large and positive, as seen from the table below. When x is minus 2, y is 5. When x is minus 2.5, y is 8. When x is minus 2.9, y is 32. When x is minus 2.9999, y is 30,002. You can put this information on your sketch using short lines near the asymptotes, like this. It is impossible for the 3 over x plus 3 part of the function to take the value of 0. Therefore, it is impossible for y to equal 2, and so the line y equals 2 is an asymptote. Mark it on your sketch. You can now test what happens as you approach this new asymptote. As x approaches plus infinity, the function approaches an asymptote from above. When x is equal to 10, y is equal to 2.23. When x is equal to 100, y is equal to 2.03. When x is equal to 1000, y is equal to 2.003. When x is equal to 100,000, y is equal to 2.00003. As x approaches minus infinity, the function approaches the asymptote from below. When x is minus 10, y is 1.57. When x is minus 100, y is 1.97. When x is minus 1000, y is 1.997. When x is minus 100,000, y is 1.99997. You should mark this information on your sketch. Finally, you can work out where the function crosses the axes. When x equals 0, y equals 3 over 3 plus 2, which equals 1 plus 2, which equals 3. So the y-intercept is at y equals 3. Mark this on your sketch. When y equals 0, 0 equals 3 over x plus 3 plus 2, which is solved to give a root of x equals minus 4.5. Mark this on your sketch. Combining all this information about the function together with the knowledge of the shape of a simple reciprocal function produces the sketch to the right. Sketch of the function y equals 3 over x plus 3 all plus 2. 3. Are there any stationary points? If so, where are they and what is their nature? It is important to gather as much information as possible before beginning to sketch a graph. Many functions have stationary points, points at which the graph of the function has a gradient of 0. There are 3 types of stationary points: maxima, minima, and points of inflection. The position and nature of stationary points can be found by using differentiation. See study guides, stationary points, and finding stationary points, and can prove to be extremely useful when you are sketching a function. Let's return to the first example in this guide. Example: sketch the function y equals x squared minus 4x minus 5. You already know that the y-intercept is at y equals minus 5, and the roots are x equals minus 1 and x equals 5 from the work done in the first example. However, you can improve your sketch by using differentiation to find the position and nature of any stationary points. By differentiating the function y equals x squared minus 4x minus 5, you can see that y by dx equals 2x minus 4, which equals 0 when x equals 2. As there is only one solution to the equation, there is only one stationary point. Substituting x equals 2 into the original function gives y equals minus 9, and so the position of the stationary point is 2 minus 9. The second derivative of y equals x squared minus 4x minus 5 is d2y over dx squared equals 2, which is positive, and so the nature of the stationary point is a minimum. You can add this information to your sketch. Notice that the sketch is not to scale, but is correct relative to the other points. This is an improved sketch of the function y equals x squared minus 4x minus 5. Further guidance and information. If you have any further questions about mathematical skills or would like to discuss any other aspects of mathematics, you can talk to your lecturer or personal advisor or make an appointment to see a learning enhancement tutor in the Dean of Students office. You can telephone 01603 592761 Email dos.help@uea.ac.uk or visit our website at www.uea.ac.uk/dos/let. There are further resources on many other aspects of numeracy, mathematics, statistics and science available from the Dean of Students Office and on its website. These include questions to practice, model solutions and webcasts illustrating essential skills. This guidance is one of a series on mathematics produced by the Dean of Students Office at the University of East Anglia.